Okay, I'm going to solve this centroid and area moment of inertia problem from your textbook. So what we need to do is to first find the centroid and then find the area moment of inertia of about the x prime axis. All right, so we have three areas, and number one area has a or shape is a rectangle, and the area is going to be 3 plus 3, that's 6 times 1. So 3 plus 3 close parenthesis times 1. And then I have 2 and 3 identical areas, only 3 shapes. So they will be equal to each will be 4 times 1, and likewise 4 times 1. Okay, so we have the areas, and the sum of areas is calculated automatically. So this is sum of AA. I could even say, like right here, sum of shift insert equals, let's see, okay, AA. Well, would like to have it the same. I could change to times New Roman. Let me take some, make some, times 1 times New Roman. And then I want the index to be italic and to be subscript. Okay, so sum of AA. There we have it. First results. And then we're looking at the centroids of the three shapes, three rectangles about the x-axis. So the first one, we read 1 inch here. So this is 0.5. Second and third, they're 2 inches from the x-axis. Okay, and then we have the products area times centroidal centroid paste. Where are you? Well, I don't care about these here. Okay, and then we add these two, or three rather, and then to calculate the centroid location, essentially y value, y over score, different notation, capital Y. We take this sum, and it is going to be divided by the sum of areas, so sum again of these three, and the answer, as you can see, is right there. So first step, and then we're moving next to calculating the centroidal areas of, centroidal area moment of inertia of the three shapes. So the first one is going to be 1 over 12 times, and then we have the width, that would be 3 times plus 3, I could just say 6 times, and the height would be at power 3. All right, so this would be for the horizontal rectangle. The two vertical rectangles, there are 1 over 12 times, and it's 1 times 4 at power 3. Okay, and likewise below. So I take this same equation, and I'm going to paste it here. All right, and this calculates the sum of moments of inertia. And then we're looking at the distances between the centroids I have these two marked. This other one is right here, 1/2 inch from the bottom. So what's the distance between the centroid, which we have it calculated here, of the shape, and centroid of the individual parts? So the first distance, it's going to be 1.357. It is y over squared minus half of the width minus 1/2 inch. So let's see. The actual value, if we're to calculate it, so we said equals 1.357 minus 0.5, and that was calculated, as you can see, automatically. This other one, and I take absolute value because it's going to be squared. So the other one is going to, or is, the centroidal value, or elevation of centroid, it is y over squared, and we subtract from it. Or rather, from 1/2 of 4 inches to subtract the centroid. So that's going to be, again, 2 minus this piece, and I have it, and likewise I can extend it and paste, so same value. Okay, so I have the distances again. We are calculating the area moment of inertia of the shape relative to the centroid axis x prime. So distance from the centroid to the centroid of shape 1 is 1.357 negative 1/2 of inch. And then the distance from the centroid, the x-axis through the centroid of body 2, is going to be 1/2 of 4 inches, 2 inches minus 1.357. So I've got these distances. And now I take the area and multiply by the distance squared. The area multiplied by the distance squared, and I believe these zeros. Okay. And then lastly, I take these, or rather, centroidal area moment of inertia of the individual part time, or plus area times distance squared. So and then I can expand it, and then below I don't need the zeros. Okay, so this is the sum of the parallel axis terms, this sum of centroidal values. I don't think we need them. This is what we need. Balloon boldface, and it's repeated here. Okay, so this is it. I could actually move this guy all the way, or I don't know, undo and center maybe. So really, this is it. There is a second approach. Let's see. I could. So let's repeat this calculation. So we write this down. The results. Copying this. Copy and paste them as values. Alright, I don't care about this. So one is the location of the centroid, the other one is the area moment of inertia. So we'll keep these as references, and I said we can try a different approach, and that will be to assume, I'm preparing the figure in a second. So some size and make this color yellow. Let's say yellow. All right, and we'll have two bodies. You probably see the spreadsheet. I see it right here. So let's see, color is, let's pause the recording really. Select all, copy. All right, so back to the spreadsheet, and now I'm going to assume just two shapes. So these were values from before, and I'm going to delete this 3 and these here, and we're having only two parts. So all right, so there's two parts. I need to delete these all here. Area 1 will be the full rectangle, which is 3 plus 3, that's 6 plus 2, 7 times 4. So equals, well, I said 1 plus 3 plus 3 plus 1 times 4. Okay, and then we're subtracting the yellow area, which is negative, and we have 3 plus 3, and then times 4 minus 1, which is 3. Okay, so subtracting the yellow area, which is 18 negative here. The centroid of the, about the x-axis, centroid of the like a full blue piece is going to be 2. So 4 divided by 2, and then for the yellow rectangle, I have 1 plus 3 divided by 2. So equals to 1 plus 3 divided by 2. All right, so the centroid of the yellow piece is at an elevation 1 plus half of this distance, which is 3. All right, so 1 plus 3 over 2. And then this is it. We have the products and areas, or area times elevation y of centroid, and as you can see, we've got the same value. It's expected. Let's see, format cells, number only 2 decimals, 3 that is. Okay. All right, let's look at area moment of inertia. We have two rectangles. One is the full, that is 3, 6 plus 2, 8. So equals 1 over 12 times the width. That's again 1 plus 3 plus 3 plus 1. And then, so 8 times the height is 4 at power 3. And then the yellow rectangle centroidal moment of inertia is 1 over 12 over, or at the times, sorry, 3 plus 3, and then times 4 minus 1, the 3 at power 3. Okay. Next, we calculate the distances. Oh, by the way, this has to be negative. All right, and we've got the same answer as expected. So the spreadsheet calculates the distance, absolute value, the distance between the centroid and the centroid of the individual parts. So would it be 1.357, or rather 2 minus 1.357 for the entire rectangle, 8 by 4. And then the other one would be the what is it, the 2.5 from the x-axis. We've got this before, minus centroid. And then we have the area times distance square. And then we have centroidal moment of inertia plus area times distance squared. Sum them, same values. So I think this is it, 16 minutes of recording. I hope this was useful.